Hi everyone, this is week 6 tutorial 4, and today our first task is about solving least squares method to find the best fit function of the form y is equal to a0 plus a1 times x, and we're given some data for x and y variable here. So let's start working on this now. Let me first write the form that we have to reach, which is y is equal to a0 plus a1 times x, and then let us even write, no, we don't need to write the values now, we can write them later. So first let's write the residual, which is e of ei, and then the residual will be observed value, which is yi, minus the predicted value, which is a plus or a naught plus a1 x. Now we can write the sum square residual. So the sum square residual would be the summation from I is equal to 1 till n of yi minus a naught plus a1 x squared. Now, to minimize the sum square residual, we have to find out the partial derivative of it with a naught and a1. So first let us find out the partial derivative of it with a naught. So for this, using the chain rule, we'll have here summation from I is equal to 1 till n 2 times yi minus a naught, so I'll open the bracket now, and a1 x times, we will now have partial derivative of what is inside. So yi is a constant for us, so that becomes a 0. a1 x is a constant, so that becomes a 0. Since we're only deriving it with a0 here, so it is minus 1 a0, so we'll only take the constant, which is minus 1. And this, if you simplify it further, it will be, so here we have, you can say, okay, let's say this is equal to 0, so we multiply both the sides with minus 1, so that deletes the minus 1 here, and then we divide both the sides with 2, so that deletes the 2 here. So now we'll have, in a more simplified version, summation from I is equal to 1 till n, not 2. We'll have here yi minus a naught minus a1 x is equal to 0. Okay, now we can continue simplifying this more, maybe. So I'll put the summation for every value inside. So we'll have here summation from I is equal to 1 till n, y of I minus summation I is equal to 1 to n a naught minus summation I is equal to 1 till n a1 x. So this is equal to 0, and now we can write it as we can write here it's like summation of I is equal to 1 till n of yi is equal to, we'll take these two values on the other side, so it will be plus now summation of I is equal to 1 till n a0, but now we don't need to write because a0 is being summed n times, so we'll just write n times a0 plus we have here we have a1 is a constant, so we can write it outside the summation. So we have I0 to n, we are working on the x, so you can, this is actually xi, yeah, so that makes it more clear. So now we are done. This is our equation 1, you can say. And now we'll do the partial derivative of the sum square residual with respect to a1. So with respect to a1, the partial derivative, so we'll have here now summation of I is equal to 1 till n. With the chain rule, we'll have 2 times yi minus a0 minus a1 times xi, and then for the partial derivative of a1, so these two yi and a0 are constant, so they are just zeros, and here we have minus a1x. So from this we'll take the value minus xi is equal to 0. Now we try to simplify this more. This will be, so here we'll again, like before, multiply both the sides with -1, so the minus sign over here will go away, and then we'll divide by 2, so both the sides and the 2 will be gone too. So therefore we'll have it more simplified now. We'll have it summation of I is equal to 1 till n yi minus a0 minus a1 xi times xi is equal to 0. So this now, if you simplify it further and we take the summation inside and also multiply all of these terms here by xi, we'll get here summation from I is equal to 1 till n xi yi minus summation from I is equal to 1 till n a0 minus summation, okay, here we'll have here xi2, so here a0 xi minus summation from I is equal to 1 till n a1, and xi will be squared because you have 2 xi multiplying, and this is equal to 0. So writing it more simplified way, you can write it as summation of I is equal to 1 till n xi yi is equal to, taking these two terms on the other side, which is a0 term and a1 term, like we did in the previous equation. So we'll have here now, so we'll take the constant a0 outside, and summation of I is equal to 1 till n of xi minus, so sorry, it's plus now, and a1 also we can take it outside, and then we have summation from I is equal to 1 till n of xi squared. Okay, now these two equations, the equation 1 and equation 2, we can write it as a matrix form, in the form Ax is equal to b. So we'll have here the terms of a0 and a1 of both of them here, a0 and a1, the terms only without the variables or without the constants a0 and a1. We'll write it here in this matrix, so it will be n for a0 of the first equation, so here it is n times a0 and summation of xi times a1. So we'll write here summation of xi from I is equal to 1 till n, and here we have for a0 term summation of xi again, and for a1 term we have summation from I is equal to 1 till n xi squared. And then we have the two unknowns a0 and a1 would be equal to, what is on the other side of the equal to sign, we have for the first equation summation of yi, and from the second equation we have summation of xi yi. Now we can arrive at our equations here. So that's like taking the first row times first column is equal to the b vector here. So that's exactly what we did in the first equation here, right? So if you do that, so you'll have n times a0 plus summation of xi times a1 is equal to summation of yi. So that will be, if you try to simplify it from the equation 1, you will get here a0 would be equal to summation of yi from 1 to n minus a1 times summation of from y is equal to 1 till n summation of xi, and then this will be divided by n, so we divide each term separately by n. And you know that the summation of I divided by n is like the average of y, and the summation of xi divided by n is like the average of x, so we can say this is average of y minus a1 and average of x. So that's how we'll find out a0 later on. And now if we put the value of a0 inside the equation 2, so you can say, let me write it down, put a0 in equation 2. This will give you how to find out a1, and the formula for a1 will be n times summation of I is equal to 1 till n xi yi minus summation from I is equal to 1 till n xi and summation from I is equal to 1 till n yi divided by n times summation of I is equal to 1 till n xi squared minus the whole thing of the summation from I is equal to 1 till n xi squared. So now let's start working on our table to get all these values here. So we need xi times yi, summation of the xi, summation of the yi, summation of xi squared, and the whole summation of xi squared. So we need to work for like these values here. So we need to find out this one here, this, and this, and we'll create a table for that. So now okay, so let's write the values of x first. So here it will be xi, then yi, and then we'll have xi times yi, and then we'll have xi squared, right? So here we have the xi, and then the yi's, xi times yi, and xi squared. So from the slides we already saw our values are -1, 0, 1, 2, and for the yi we have -4, -1, 2, and 4. So let's write them down now. So we have here -1, 0, 1, 2, and here we'll have -4, -1, 2, and 4, and here we have 4, 0, 2, 8, and here we have 1, 0, 1, and 4. And now we'll sum them up. So we'll calculate the summation of all these values. So here, if you sum these up here, you get 2, and here the summation of all of these is 1, 14, and 6. Okay, once we are done with this, now we can easily work on A1. So let's take the formula from the other page. Let's take the formula for A1 here. Okay, so now A1 is equal to n. So what is n for us? N is the number of terms that we have. So as you can see over here, we have 4 terms. Like for xi we have 4 terms, 4 data set, or you can say points, right? So n is equal to 4. So we have 4 times the summation of xi, yi, which is 14 from here, minus we have the summation of xi, which is 2, times the summation of yi, which is 1, divided by n, which is 4, times summation of xi squared, which is 6, minus we have summation of xi, which is 2 here, and then we take it and we square it, right? So this will give you the value for A1 as 2.7. And now we know from before A0 is equal to, from here, y, average of y minus A1 times average of x. So we have average of y minus A1 times average of x. So average of y is the summation of y here, which is 1, divided by the total number of terms that we have here, which is 4, which is n, minus A1, which we already received here, which is 2.7, and then times x average, which is summation of the x values, which is 2, divided by n, that is equal to 4. And if you solve this one here, you will get for A0 the value minus 1.1. So we can say now we can write the numbers now in the form that we wanted to write it at the beginning, which was y is equal to a0 plus a1 times x. So now we have the numbers for a0 is minus 1.1 plus a1 is 2.7 times x. So this is our final line equation.